for x again, random variable. Okay, now go to chapter 3a when we talk about the sampling distribution. Okay, this is called sampling distribution. Okay, sampling distribution is like this. Okay, so if the number of the sample increase or go to the infinity, it will just like behave, behave what? Normal. Okay, so this x-axis, okay, it could be any statistic. What is mean by statistic again? It could be sample mean. Okay, it could be proportion, it could be variance, okay, it could be standard deviation, it could be the difference between two mean. Understand? So this is called statistic. Again, what is statistic? It's the parameter that you obtain from the sample. Okay, usually they will give you n is equals to what? For the sampling distribution. Okay, understand? Okay, so this is the difference between the sampling distribution with probability distribution, and I have discussed few questions that is related to the sampling distribution for the mean. Okay, for the mean. Okay, let us further look at this question. Okay, now this question I have not discussed these two questions yet. Let's see. Okay, are you able to solve this question? Okay, again, now they are talking about an electrical firm. Okay, they are doing the light bulbs that have a length of life that is approximate to normal. They tell you the mean, which is equals to 800 hours and a standard deviation of 40. Find the probability that a standard, okay, look at this, how we know that it's sampling distribution. They ask you to find the probability. They give you the number of sample. First thing, at the first place, they tell you n is equals to 16 already. Find the probability, okay, find the probability of n is equals to 16 to have average. So you know that this is sampling distribution, okay, which is less than 775. Understand? Okay, so you must write down what is the meanings of this question and then what is the requirement of this question. Okay, at the end, the objective of this question, you need to find the average is less than 775. Okay, so again, from here, the situation from this question is like this. They tell you mean, okay, they tell you the mu is equals to 800 with the standard deviation which is equals to 40. Now, from one random sample, okay, random sample with n which is equals to 16. Imagine that you have 16 sample now. From here, we are able to calculate the x bar, which is equals to the sample mean. Okay, now the question asks you what is the probability of this sample mean that is calculated from this sample size, which is 16, that will have less than 775. So this is called sampling distribution. Okay, how to solve this question? So again, okay, so we know the mean is equals to 800. Okay, less than 775. Less than 775 means somewhere here. 775. Understand? So you are required to find the probability less than 775. Okay, how to solve it? We have to change it, transform it to the standard normal form. Okay, if we change to the standard normal form, mu is now become 0. Okay, then we have to find out what is the value of z in this case. So how to calculate the z? We use this formula for the sampling distribution. X bar minus mu divided by the standard deviation divided by square root of n, because this is sampling distribution. Alright, so with this formula, we are able to calculate Z is now equals to 775 minus 800 divided by standard deviation given as 40 divided by square root of 16. Okay, so what is the value of Z? What is the value of Z? In this case, it must negative because at the left hand side, what is Z? Negative? You should get 2.5, right? Okay, so for this negative 2.5 means that what is the probability? Hence, you just need to figure out what is Z less than negative 2.5. So what is the meaning? Huh? So you will get 0.00625. Okay, how to get this? From the appendix A. Okay, from the appendix A. Okay, so this is the question related to, okay, so if you look at this question, this is sampling, okay, distribution of sample mean. Okay, so this question is belongs to sampling distribution of sample mean. Okay. Okay. So actually the solution is not provided. Okay, so I already give you the solution. All right. So let's see. Okay, there is another question. Equals to 10. So you see, we can get the information as such. Okay, mu is now equals to 100. Standard deviation is equals to 10. And then they tell you that the distribution is normal. Why? Because from the central limits, we said already, when the n is increased, we can assume that it is normal. That is why we can use the normal distribution to solve this kind of question. Okay, and then, okay, find the probability that for a random sample n, which is equals to 25. Again, they tell you about n. Find the probability that will have average. So what does this mean? Sample mean. To have less than 95. Okay, so again, it's like this. For the sample size, which we have the n is equals to 25. Okay, from here, we are able to calculate x bar. Now we need to figure out what is the probability that this x bar that you obtain is less than 95. Understand? Understand? So this is called sampling distribution of sample mean. Okay, again, this is called as sampling distribution. For what? For sample mean. Okay, so with this, we know the solution is similar with the previous question. Okay, so in this case, it's like this. Okay, the mu is 100 at the center. Now we need to find what is the probability less than 95. Again, we have to change this to the standard normal form, whereby standard is 0. Okay, then what is the z value? Convert it. Z is equals to x bar minus mu divided by sigma divided by square root of n. Okay, so it is now equals to 95 minus 100 divided by 10 divided by square root of 25. So what is the z value that you will get? Is that equals to negative 2.5? Kind of. Is that equals to negative 2.5? Yes, that means that the answer here should be the same with the previous question. Okay, so z less than negative 2.5, hence the answer is equals to, okay, 0.0062. Okay, this is the answer. Okay, all right, so this is the solution. I hope with this example, okay, you already understand what is the difference between probability distribution and sampling distribution, and particular for this question is related to the sampling distribution. Okay? Sampling distribution of mean. Understand? Of mean. Okay? So this is one of the statistic sample mean. Okay? It could be other parameter, for example, proportion. But I will skip this part first. I will come back to this when we talk about the confidence interval later on. Okay, it could be proportion. Let us see another example. Okay, I want you to look into this. Sampling distribution, different of two means. Okay, different of two means, what does this mean? We have two population. From here, from the sample size, we are managed to calculate the sample mean. Okay, so for another population, we are able to calculate the sample mean for second population. Now, we want to know that what is the difference between the mean. Understand? So this is called difference of two means. Understand? This is one of the statistics. Okay, one of the statistics which involve two population already. Okay, so sampling distribution, different of two means. Okay, so x bar 1 minus x bar 2 can be normally distributed. Why? Because from the central limit theorem, okay, it is said to be if the n increase, it is approximate to normal. Okay, how to calculate the mean? It is mu1 minus mu2. How to calculate the standard deviation? Okay, it's that square root of variance divided by n1 plus variance of from the second population divided by n2. Okay, we will need to apply this to solve the sampling distribution of two different means. Okay, what is this and how to use it? I will explain from this example. Okay, I will give you 1 minute to read through this question and then see what are the information that you can capture from this. Okay, so please read through this question. Why this is said to be sampling distribution for difference between two means? Okay, look at the question first. Okay, so I will write down the information first. So from this question, we know that they have two populations. Okay, it is said to be A and B. Okay, we have two company, two manufacturer, A and B. Okay, if you look at this, from the manufacturer A have a mean lifetime of 6.5. Okay, so from here, 6.5. So what is the meaning? Mu1 is equals to 6.5. Okay, and then standard deviation of 0.9. Standard deviation is equals to 0.9. Okay, from this population, okay, the random sample will be collected from this. Okay, so how many sample will be collected from A? 36 from A. Hence, this is sample. Okay, N is equals to 36. Understand? Okay. Then from this sample with n is equals to 36, we are able to get x bar 1 can be calculated. X bar 1. Okay. Then from the component B, let us look at what are the information that is given here. So mu 2 that tell you is 6, okay, and has a standard deviation of 0.8. Sorry, salah here. Okay, so this one should be mu sigma 1. Okay, so this one will be 0.8. Okay, so let us look at the question, and then from this sample, okay, from the population B, number of sample will be collected is 49. Okay, of course from this n is equal to 49, we are able to calculate sample number 2. Okay, sample mean of 2. Okay, then look at the question. What is the probability? Okay, in short, okay, what is the probability that the random sample of 36 will have a mean lifetime that is at least 1 year more than B? At least 1 year more than B. Okay, so what is the meanings of this question? Actually, you need to turn it to the mathematical equation that this is referring to P, x bar 1, minus x bar 2, is greater than 1. At least 1. Of course you can put it like this. At least 1. Can you see the question? So A greater than B at least 1 means that x bar minus x2 must be greater than 1. Understand? Can see this? So this is called sampling distribution. This type of question, it belongs to sampling distribution of different of two means. Different of two means. Because it's involved two population, then we need to find the difference between it. So again, how to find the mu x bar 1 minus x bar 2, the difference. Hence from here we know that it is mu 1 minus mu 2. So mu 1 minus mu 2, we will get 6.5 minus 6. Hence we will get 0.5. The difference between the mean is 0.5. Understand? Then how about the next one? The difference of standard deviation. So the difference of the standard deviation, x bar 1 minus x bar 2, follow the equation. It is square root of, copy the equation. So this is calculate the value for me for this. So this is 0.9, square divided by 36 plus this is 0.8 square divided by 49. What is the answer that you will get from here? What is the answer that you get from here? What is the standard deviation? The difference between two standard deviation. Anyone get this answer? What is it? 0. Yeah, 0.189, right? Okay, so 0.189. Okay, now we have these two information ready. Again, so let's see how we can solve this question. Again, now, okay, we know that it is normally distributed. Okay, so what is the standard here? Standard here is the mean for the difference of two means. This is standard is now equals to 0.5. We want to know what is the probability that the difference is more than 1. Understand? Okay, all right. So again, how to do this? Change it to the standard normal form. Okay, now the standard will have the value which is equals to 0. Okay, so what is this z value? Okay, again, how to convert it? Z is equals to general equation. We have think about x minus mu divided by sigma, general equation. Hence now we know that this is now equals to 1 minus 0.5 divided by the standard deviation that we already calculate based on the number of samples. Hence, we just substitute this value, 0.189. So what is the z value that you get from here? Is equals to 2.6 what? 65. Okay, 65. Okay, then can you calculate what is the probability that is more than 2.65? So P Z more than 2.65, it is equals to 1 minus P Z less than 2.65. So what is the answer? So you will get, refer to the appendix, you will get 1 minus 0.9960, hence is 0.004. Okay, so this is the solution. Okay? All right, everyone? Okay? All right, so this is the discussion about the sampling distribution. I have discussed two types. One is sample mean, one is the difference between two sample mean. All right, so you must know this is called sampling distribution. All right, so right now I will move to the next chapter, which is 3B. Okay, I will going to introduce what is meant by point estimation and confidence interval. Okay, for one parameter only. I will not cover too much for today. Okay, Alright, so I will go very slow because chapter 3 and chapter 4 somehow is related, and it is very important because sometimes chapter 3 and 4 already contribute 50% of the examination. Yeah, okay, so I will spend about 6 weeks just to finish 3 and 4. Remember chapter 4, okay, I will give you your assignment, okay, during when I discuss chapter 4. Okay. All right. So I think I will continue. We could finish earlier, but I will continue for this. Okay. So now let's go to the next topic, which is called estimation. Okay. So again, back to the basics of the statistic. Okay. So you must know what is different between population and sample. Okay. So please remember that. Okay, whenever we do case study, very hard for us to get the data from the entire population. That is why we always collect a sample. So from this sample, we use this sample because from this sample, we are able to calculate the exact value. For example, we can calculate the sample mean. For example, we can calculate the sample standard deviation. We can calculate the sample variance and then sample proportion probability from this because the sample size is small. Understand? Okay, so then what is this for? All these parameters we are called as point estimation. For example, if you want to know the average age of the student, we collect a sample and then we calculate. We find out that the sample mean X bar is equals to 23. What does this mean? This 23 is point estimation. We estimate what? We use this point estimation, a single value, to estimate the population parameter. What is population parameter? So this is sample mean. Correct? Sample mean. So we use X bar to estimate population mean. Understand? One by one, one to one. And then, okay, we use sample variance to estimate population variance. Okay? We use sample standard deviation to estimate sample population standard deviation. We use sample proportion to estimate population proportion, which is we use the symbol of pi. Okay? Okay? So this is called point estimation. We use a single value. Understand? Okay? Alright. So again, this is what we estimate. We estimate different value. Okay? So again, okay, you must know the symbol of this. What is this? Pi refer to population proportion probability. Okay, what is mu? Population mean. Okay, what is this? Population variance. Understand? All these are the parameter. What is mean by parameter? The measurement that you obtain from population. Remember this, okay, we stick to this symbol, okay, you must understand, you must know what is this symbol mean, okay, okay, so how to estimate? We can have point estimation, single value. Later, I will introduce the confidence interval, okay, confidence interval in certain range, okay, point estimation. Okay, so let's see what is meant by point estimation. Is the single numerical value of the statistic. So we call this as point estimator. Okay, point estimator. Alright, so like this. Again, one to one. Okay, we use X bar to estimate the mean. Okay, we use sample variance to estimate population variance. Okay, so that is the meanings of this one-to-one estimation. All right. So of course, best point estimation, it should be unbiased, smaller variance and efficient estimator. Okay, how to get the best estimator? It should fulfill this criteria, but this is not important. Okay, let us go through this first. Okay, the most important is the confidence interval. Okay, so what is mean by confidence interval? What is mean by interval? What is mean by interval? You must know that it must within a range. Okay, so if you have lower limits, okay, if you have upper limits, okay, so this is called interval. Confidence, later we will give the indicator for this. How confident? 90%, 95%, 80%, etc. And then what is the meanings of this confidence interval? Okay, I will go through this. Alright. So confidence interval is stated in this form. Okay, 23 for example, plus minus 1.5. Okay, if it is represented in the range, 23 is at the center. Plus minus 1.5 means what? This 1.5 means margin of error. Okay, so plus minus means that 23 minus 1.5, you get 21.5. This is lower control limits. Okay, lower limits. If we have 23 plus 1.5, we get upper limits. So this is called confidence interval. Understand? Okay, so confidence interval, we are measured in terms of percentage. Okay, that is why in the statistic you always heard about this 90% confidence, 95% confidence, and 99% confidence. And then for the 95% is the most commonly used indicator. Okay, we have always said that 95% confidence, your value will fall within this range. Alright, so we will talk about this confidence interval for today. Okay, so what is the meanings of 90%? So this is just give you some idea. Okay, when we say about 90% confidence, let's say we have 10 interval. Okay, 9 out of 10 contains population mean. You see, the population mean is here. Out of 10, only 1 outside the range. So in this case, we said 90%. Only 1 is outside the range. Okay, so 9 out of 10 contains population mean. So this is the idea for 90% confidence. Okay, then how about 95? When we say 95% confidence, 19 out of 20 contains population mean. Okay, so only it should be 2 out of the range. Okay, sorry, it should be 1. 19, okay, out of 20 contains population means. In this case, we can say 95% confidence level. Later, we will calculate what is the meanings of this 95, what is the meanings of 90. Alright, so before that, okay, so we will introduce this alpha. Alpha is the level of significance. Okay, level of significance. Okay, level of significance. Alpha is equals to level of significance. Okay, so how to get this? Okay, so it's equals to 101 minus alpha. What is the meaning? Okay, I will skip some of this. Okay, I will go through this first, this one later. Okay, let's see. Let's start with the first one. Okay, how to calculate the parameter estimation confidence interval for the first one. If you look at this, it involves a lot of the formula here. So look at this. Today I will just only focus on this. That is why I said that I will spend a lot of time in chapter 3 and 4. Okay, so for today, let us just focus on the mean. Okay, we could have difference between two mean. We can have variance, we can have ratio of variance, we can have proportion and difference between two proportion. Okay, so mean further divided into three different criteria. Okay, so we have to look into that. If the population variance is known, okay, is unknown, in this case n is large, or population variance is unknown but the n is small. We have three categories. Alright, so how to construct the confidence interval for the population mean? Okay, let's see. It is written in this case. What is this mean? X bar. Sample mean. Okay, what is this mean? Approximate to normal. Correct? Okay, normal. Okay, what is mu? Population mean. What is this? Population variance divided by n, because it's sample. Okay, so of course we need to change it to the standard normal form. Z approximates to n. 0, 1 means what? This is mean by standard normal distribution. Understand? So how we can convert x bar to z? We are using x bar minus mu, okay, divided by square root of sigma square. Of course, it is the same for this equation as well. Just now, okay, you can, if the question give you standard deviation, you can calculate as this also can. It's the same formula. Okay, it is the same. All right. Now, by using this general equation, okay, let's see different criteria. Okay, so from this later, I will show you lots of the formula. Okay, I will explain it later. That is why later we can get 1 is minus, 1 is plus. With this, we say that it is two-sided. Okay, lower confidence limit, upper confidence limits. This is what we call confidence interval. Okay, but I will not show you this formula first. Okay, so here the general equation. Confidence interval for the mean can be written as this. Okay, just show you. And then it has three different cases as I just now. Okay, so first case, in this case, known population. Okay, and then we have to use this plus minus. If unknown population, okay, we have to use this formula. What is the difference between these two formulas? Can you look into this equation and tell me what is the difference? Since non-population means that non-population variance means that they will tell you this value. Hence, in this equation, the population standard deviation is used. Okay. Second case, if the population variance is unknown, hence we have to use the sample variance or the sample standard deviation. What does this mean? What does this mean? Why we have Z? Remember how we get the confidence interval? We have x bar plus minus e. E is the margin of error, right? Not? So they use Z. Z means what? Z means what? Normal distribution. We are using normal distribution. Okay. If you look at C, if the n is small, how small? Less than 30. If the n is large, how large? More than or equals to 30. So this is the indicator. If you compare this with this, what is the difference? The formula. Can you compare the formula? One is using normal, the other is using another distribution. In your appendix, it is appendix B, which is student T distribution. Okay, yeah, so we will have another set of distribution. Okay, but I will show you one by one. All right, now, okay, that is why with this, okay, I will show you one example first. Okay, let us have a look for this slide. When we talk about confidence interval for the mean, okay, general equation is x bar plus minus e. E is the margin of error. This e, okay, if using case number 1 just now, we assume that this value is known. So z alpha divided by, z alpha divided by 2, okay, sigma divided by square root of n. Okay, in Excel, this E can be calculated using confidence, but I will not talk about this later. I will talk about this during the tutorial. We can use Excel to calculate the margin of error. Okay, but now, how to calculate this E? Okay, Z alpha divided by 2. If we say that we want the confidence interval to be 95, what does that mean? What is alpha? Alpha is level of significance. Okay, it is equals to 1 minus 0.95, hence is equals to 0.05. Okay, so what is the meanings of 95% confidence? Let us have a look for this. You know that this is normal distribution, and then 95% here contribute 0.95. Understand? Okay, so here we have lower sided and upper sided here. So how to calculate 0.025? Because it is symmetric, and then to calculate this value is equals to 1 minus 0.95 divided by 2. Because when you sum up this value, it must be equals to 1. When we talk about 95% confidence, this is the meaning. Okay, and then what is the value? Must fall within 0.95, 95% confidence. Alright, so this is the concept for the confidence interval, which is 95%. Okay, so how to get this value? Okay, how to get Z 0.025? Can you see this? We know that this is 0.025 from the normal distribution table. Okay, so what is the Z value that will give you 0.025? What is the value? Look at this. Hence is equals to negative 1.96. So this value will take 1.96, and here will take 1.96. Understand? Okay or not? Okay, that is why Z alpha divided by 2 will take 1.96. Okay, that is how we get this value. Okay, so I'm not sure you understand or not, but I will show you this example, and then okay, let's see what is the meaning, how to apply it with all the confidence interval. Okay, so let's start. Okay, for this question, okay, so you see the score on an exam are normally distributed with population standard deviation of 5.6. Let us have a look for this. They give you this information. Okay, a random sample of 40, n is equals to 40. Okay, and they tell you that a random sample of 40. Okay, so because they collect the sample which is equals to 40 students, and then they calculate the x bar. So the x bar is calculated as 32. Okay, so estimate the population mean. Okay, estimate the population mean with 80% confidence, 90% confidence, and 98% confidence. Okay, again, so based on this, we want to calculate the confidence interval for population mean. Okay, how can we estimate this? We use x bar. Okay, in this case, we must look at this formula. Okay, you must know that, okay, here. This is confidence interval for the mean. It has 3 different cases. In this question, okay, first, since the population variance or the standard deviation is given, this is case 1. So if it is case 1, we have to use this formula to calculate the confidence interval. Okay, so how to calculate it? Okay, I will show it one by one. Okay. Okay, the solution is given here, but I will write it again. Alright. Okay, so A, I will do it again. Okay, so now we know that x bar plus minus E. Okay, from the question, we know that this is case 1. Okay, why case 1? Population variance is given. So I know that I have to choose this formula. Okay, I have to choose this formula. X bar plus minus Z alpha divided by 2. Okay, then sigma divided by square root of n. Okay, you see, if we have this equation, okay, from the question we know x bar. X bar is what? 32, right? Okay, population variance is known, is 5.6, right? Okay, so what is n? N is 40. Okay, now the next question is, what is this? Z alpha divided by 2. Alpha divided by 2, what is alpha in this case? This is 80%. 80% means what? Here is 0.8. Correct? 0.8. Okay? So, in this case, what is the value for this? Both. This is 1 minus 0.8 divided by 2, hence this contribute 0.1. Can you find what is the value of this Z? That will give you 0.1. Okay, 0.1. If you look at this, okay, 0.1. Can you see the nearest one from the table? Negative 1.28. Okay, so this value will take negative 1.28. This will take 1.28. Because it's 80%. Understand? Okay, so now when we substitute back to this equation, so this value will take 1.28. Because here is already include plus minus, we just take the positive value. Okay, so how to get the lower limit and upper limit? Okay, so the calculation is like this: 32, lower limit minus, okay, 1.28, okay, then times 5.6 divided by square root of 40. Then you should get the lower limits at 30.87. Understand? Okay, how to get the upper limit? So 32 plus 1.28 times 5.6 divided by square root of 40. Can you check if you can get these two values? Can? Okay, so with this, we get the lower limit and the upper limit. In this case, since it is 80%, okay, so we are 80% confident that the population mean score is between 30.87 and 33.13. Understand? So this is called confidence interval. How confident? In this case, 80%. How we set 80% in this case? Okay, so this is the first question. If you don't understand, never mind. We have a lot more question for this. Okay, so let's move to B. How about 90%? Okay, I will do again. So 90%, think about general. Okay, x bar plus minus e. Okay, since this is case 1, hence we use the formula x bar plus minus z normal distribution alpha divided by 2. Okay, because we want to find lower and upper limits, the formula is sigma divided by square root of n. We use this formula. Okay, you see, we get all this the same. The x bar is 32, right? Okay, so this is 56, 5.6. This is m is equals to 40. Okay, the only difference is this part only, z alpha divided by 2. Now is 90%. What is mean by 90%? For the normal distribution, 90% it must be symmetric, because we have lower and upper bound. This will be covered 0.9. 0.9, okay, 0.9. Then how about here? We need to find what is the value of this z. How to find? 1 minus 0.9 divided by 2. Here we get 0.05. Okay, this contributes 0.05. Our objective, we need to find what is the value of z here. How to find? From the table. Okay, remember this value is in between. So remember this value, negative 1.645. Okay, so you can use 1.64, 1.65, but the most accurate value here, negative 1.645. Understand? So we get this value already. Okay, z alpha divided by 2 is 1.645. Okay, you no need to put the negative because plus minus is already included. Plus and minus, we just need to know the value of z alpha divided by 2. Hence, in this case, substitute the value into this again. So you will get, okay, the lower limit is equals to 32 minus, now is 1.645 times 5.6 divided by square root of 40. Okay, how you get upper limit is 32 plus 1.645 times 5.6 divided by square root of 40. Okay, so you get this as the confidence interval. Okay, so in this case, we get another range for the 90% radio. Understand? Then move to 98%. Okay, 98%. Okay, let's see. Okay, I will start from here already. X bar plus minus, again the same formula, alpha divided by 2, sigma square root of n. Okay, so again we have all these value. This is 32, this is 5.6, this is 40. Okay, now again we need to figure out what is z alpha divided by 2 for 98%. Okay, if you look at this, 98% is like this. Here covers 0.98. And then how to get 0.01 is 1 minus 0.98 divided by 2, hence 0.01. What is the value of z that will give you 0.01? Refer to the appendix, find the nearest value, 0.001. It is referring to negative 2.33. Okay, hence this value 2.33. Understand? Okay, so again, how to get the lower limit is 32 minus 2.33 times 5.6 divided by square root of 40. How you get upper range is 32 plus 2.33 times 5.6 divided by square root of 40. Hence, we get the confidence interval for 98% confidence. Understand? Okay. With this, let's see the summary from this this question. Okay. Let us have a look for this. We get 3 range subject to the different confidence. Again, how we determine the confidence level is because of this alpha level of confidence. Okay, so with this we get 3 range. Okay, so we say 90%, 80%, 90%, 98%. Okay, so if you compare the range, okay, it's like this. So this is 80%. Okay, if we compare with 90%, it's somehow like this, correct? Correct? How about 98%? This is 90%. Okay, this is 80%. This is 98%. Can you say 100%? Can we say 100%? Why? Why cannot say? 100% means what? Means that here negative infinity to positive infinity. If 100% means that you no point doing statistic, because doing statistic we limit our data so that we are confident that 95% confident is must somewhere around the range. So 100% means that negative infinity go to up to 100 infinity. It doesn't mean anything. Okay, so normally we set confidence level at 95%. Okay, alright, so this is the meanings of the confidence interval. Is that okay? Can? Okay, do you want to take 5 minutes break? Okay, we take 5 minutes break. We want you to focus, okay, at least in your mind, okay? So you must understand what is confidence interval, okay? So we have 95, 90, okay, percent of the confidence interval. And then remember, okay, so I have introduced the confidence interval for the mean. Okay, please sit down and I will start the discussion for this question. Okay, let us have a look for this question. They tell you that compressive strength of a concrete is normally distributed. They tell you the standard deviation. Okay, standard deviation is 2.18039 times 10 to power of 5 Pascal. Okay, they tell you this information. From this information, you know that this is case 1 already, because the population standard deviation is given. Now, okay, we don't know the mu, population mean. How we estimate the mu? We can through the sample. From this sample, okay, we know that 16 sample is collected. N is equals to 16. Out of this 16, we are able to calculate X bar. This X bar is calculated as 2.4997 times 10 to power of 7. Our objective here is we have to use the X bar to estimate mu. Again, X bar to estimate mu, population mean. In this case, they ask you to construct 95%. 95%. So 95% confidence interval on the mean. Okay, how to do this question? Again, this is case 1. 95% confident. Go to this X bar plus minus E. Must have lower limits and upper limits. Plus minus. Okay. So since this is case 1, why case 1? Because they tell you about the population standard deviation and variance. So this is case 1. Case 1, we have to use the formula x bar plus minus z alpha divided by 2 sigma divided by square root of n. So this is the formula for case 1. Okay, if we look at the information, we have this value already, which is given as 2.49978 times 10 power of 7. We have the population standard deviation given as 2.18039 times 10 power of 5. We have n, which is equals to 16. Understand? Okay, so what we need to calculate is this only. Okay, z alpha divided by 2. So since it is, think about that, this is 95%. Okay, 95% normal, z means normal distribution, 95% is like this, 0.95. Here will be negative z and positive z. Okay, I want to know the value of z. Okay, so how to calculate this? Okay, so you have to use 1 minus 0.95 divided by 2. Hence, you will get what? 0.025. Okay, what is the value that you get from here? Can you refer to the appendix and find out? Yeah, one will get negative 1.96, one will get 1.96. Okay, so what is the meanings of this? It is 1.96, so you no need to take negative value because this is plus minus. So with this, we get the confidence interval with 95% already. Okay, so now to calculate the value, substitute this value, so you get the range. So I just write down the answer, 2.4891 times 10 to power of 7. This is lower confidence limit. You will get upper confidence limit 2.5105 times 10 to power of 7. So this is upper confidence limit. Okay, so now we obtain the confidence interval already. So we have confidence. How confidence? We have 95% confidence. The population means will fall within this range. Understand? Can not? Okay, so this is estimation. No? Okay. Okay, can we use sample mean to estimate population mean? Now we give in terms of confidence interval. How confidence? 95% confidence. Understand? Okay? Can I? So this is the solution for this question. Okay, so let's move to the last example for today. This one. Now, you see, again, if you look at the question, can you tell me that this is case 1, case 2, or case 3? The objective of this question, find 95% confidence interval for the population mean. Okay, so again, it is like this. You must understand the concept. Okay, so population. Okay, we want to know the population mean, which is mu, but we don't know. Okay, how we can estimate? We can estimate through the sample. From this sample, based on the question, 10 measurements are taken. So n is equals to 10. Okay, so from this 10, we are able to calculate the sample mean, right? How to calculate sample mean? Can you calculate for me? Are you able to calculate the sample mean? Can you calculate for me what the sample mean?
这全部加起来除1、2、3、4、5、6、7、8、9、10。
What is x bar?
Yay, mantap.
Okay, you should get 64.46 like this. Okay, remember So now we use x bar to estimate. Okay, this is a process called estimation. Okay, we use x bar to estimate the population mean. Okay, alright. So can you tell me this is case 1, case 2 or case 3? Huh? Why case 2? Look at the question. They tell you what? They give you this value. Okay, so if this value is given, we no need to see the number of sample. Understand? Okay, in this case, look at this. They tell you one important parameter. Okay, they tell you now population standard deviation is 1. Means that because of this is case 1. Okay, if case 1, we have to use this formula. X bar plus minus Z. Alpha divided by 2. Sigma divided by square root of n. As simple as this. Okay, then what is X bar? 64.46. Okay, what is sigma? 1. What is n? 10. Okay, then what is left? We need to find Z alpha divided by 2. Okay, this question 95%. Okay, 95% confidence, meaning that, okay, 95 0.95, and then here 0.025, here 0.025. So again, what is the Z? One is negative 1.96, and you should remember this value already, 1.96. Okay, then what is the meaning? So this value will take 1.96. So we get all the value already. So now you can calculate the lower limit and the upper limits already. So lower limit is 64.46 minus 1.96, okay, then times 1 divided by square root of 10. Okay, so okay, then this is lower limit. Upper limits plus 64.46 plus 1.96 times 1 divided by square root of 10. Okay, lower limit, upper limit, hence now the final answer is we get this range already, 64.46. You can write in terms of this because we can estimate the population means as, okay, so this answer will be 63.83. Okay, so this one will be 65.08. Okay, so we have 95% confidence this population means fall within this range. Understand? Understand? Okay, look at the objective. Okay, look at the objective here. Okay, so we want to know the population mean. Okay, so we can't calculate it. Okay, that is why we have to perform statistic. From this statistic, we collect a sample of n is equals to 10. Okay, and then we calculate the sample mean as this. In this case, we are able to construct 95% confidence interval. Okay, at the end, we have 95% confidence. This population means will fall within this range. Understand? So we can estimate the population mean. Okay, so this is the idea of confidence interval. Is that okay? So with this, we complete the discussion, okay, for this part. The first one, this done. Okay, and then during the tutorial, we will see another type, which involve case 2 and case 3. Okay, but today I just want you to bring home what is meant by confidence interval. Has the concept, how to use X bar to estimate mean. That's all. Understand? Alright, so with this, I end the lecture for today. I will see you next week. Okay, so for those who have not signed your attendance, okay, please check your attendance. The code is 288388 for those who have not signed attendance. Okay? So, okay, happy weekend. Okay, see you next week. Alright?